This is the start of statistics, and to begin this unit, we're going to talk about, first of all, the types of data. One type of data that we're going to look at first is univariate data, which has only one variable. We will go on to bivariate later, which is where we have two variables. Qualitative data is data that is not given numerically. For example, the colour of a car. Quantitative data is numerical and can be classified as discrete or continuous. Discrete data is either data that can be counted or data that can only take specific values. And continuous data can be measured. Continuous data that can be measured is things such as height and weight. Now within this, we also have different sampling techniques. So when we're sampling data, there's different ways to sample. And we have 5 different ways here. The first one, convenience sampling. So we select the most easily accessible members of the population. So for example, if I wanted to sample 20 students out of year 10, I'm just going to go straight to my year 10 maths class and pick the first 20 that walk in the door, because that's the most easily accessible to me. Simple random sampling, members of the population selected are randomly generated. Once again, nice and easy. I want to select 20 year 10 students. I'm just going to put you all into a spreadsheet, give you all a number, randomly generate 20 numbers, done. That's my sample. Systematic sampling is where we list the members and select according to a random starting point and a fixed interval. Once again, for this situation, I would maybe put you all in alphabetical order in year 10. I would say I'm going to start at number 20, so whoever was 20 in the cohort, and then I'm going to take every 10th person after that. So then I take the 20th person, the 30th, 40th, 50th, 60th, and so on. Stratified sampling, selecting a random sample where numbers in categories are proportional to their numbers in the population. So this would be if I wanted to survey the whole school. I would look at how many in total year 10s, 11s and 12s there were, and the proportion of year 10s to the whole school, 11s and 12s, and then in my sample of 20, take that same percentage or that same proportion out of the 20 of year 10s, 11s and 12s. Quota sampling, population is split into groups based on relevant factors, and convenience sampling from each group is used. Just have a quick example here of stratified sampling. So in a school, there are 137 students in year 8, 152 in year 9, 174 in year 10, 168 in year 11, and 121 in year 12. A sample of 50 students is needed. How many should be randomly selected from each year? So this is going to be stratified sampling, where we want to take the same proportion from each year level out of our total sample. So the first thing I need to do here is work out how many students I have in total. So if I add up all the numbers, we end up with a total of 752 students in the school. Now I'm wanting a sample of 50 students, so I need to work out what proportion of year 8 make up the whole student body. So in year 8, 137 students out of the 752. That will give me the proportion, and then because I want a sample of 50 students, I'm going to multiply that by 50, and that's going to tell me I need 9 students from year 8. So I'll work out the proportion by doing the division, then multiply how many I need to get that same proportion in the 50. Then we just do that for each of the year levels. So year 9 is 152 out of the 752. That gives me my proportion. Multiply by how many I want to survey, which is 50, and that will give me 10 students that I need to survey from year 9. I'll quickly do the rest for years 10, 11 and 12 to find their proportions too. So there you have it. I've got how many students I need from each year level, and if you add all those numbers together, you will see I will get my sample of 50. Right, let's carry on with looking at some discrete data. Discrete data, remember, is data that we can count. All right, so it takes on set values, and often it can be organised into a tally frequency table and displayed in a column graph or a dot plot. So I've got 3 examples there of those 3 items, and the data in each of these 3 represents the exact same data. So the data in the frequency table is the same data in the column graph, is the same data in the dot plot. Also, one great thing about this, we can also really easily see the mode. Now remembering, hopefully from previous years of schooling, the mode is the most common data value. And in each of these 3, you can see very easily that that is 2, because in the table it's the highest, got the highest frequency. And in the graphs, we can also quite easily see that the most common one is 2, as it is the highest. So sometimes you may be asked to create each of these things. Main thing to know is with a column graph that with discrete data, there are spaces between your columns. So in discrete data, our columns cannot touch. There needs to be spaces between them. Because it takes set values of number of nights, it can't have half a night or anything like that, only the exact number. We can also have grouped discrete data. So if we have a lot of numerical data, it is often better to group the data into class intervals. And in this case, we don't have a mode, we have a modal class, which is a class interval with the highest frequency. Quick example here then of discrete data. So we have a popular wedding reception venue hosted receptions for these number of guests in the past month. Organise the data into a tally frequency table using class intervals of width 10. Put the data on a column graph and then state the modal class. So first of all, we're going to start with our frequency table. Now we're told to give class intervals of width 10. We've got to look at our data and see what our lowest number is. Our lowest number appears to be 51. So the easiest way to do this is probably go between 50 to 59. I don't have decimals here, which is why I need to go to 59 or not 60, because 60 needs to be in the next one, because 50 to 59 is 10 numbers. Then we'll go 60 to 69, 70 to 79, and so on. And we're going to go up to 109 as our largest value is 105. Then we're just going to go through and tally these up. Easiest way often to do is tally start at the beginning. So we'll start at 82, which will go into this one and put a 1. 53 would be in there, 68, and just work through, cross off once you've done a number so you know you are not doing any number twice. Now remembering when we get to 4 of a number like I have done here in the 60 to 69, my next number is 66. To make a 5, we draw a line through rather than carrying on with the lines, otherwise it gets really difficult to count. So once we get to 5, put a line through it. And I'm going to carry on and complete the table. That's my tally completed. Then we're just going to add up the sums for each. We'll have 5, 9, 3, 7, 2, and 2. Part B, we want to display the data on a column graph. You'll see here I haven't started my x-axis at 0 because there's nothing between 0 and 50. So we use this kind of symbol here you can do at the start to represent that it would start at 0, but we're missing a few numbers first. Now from 50 to 59, we have 5. So I go up to 5 on my axis. Now I'm not going to go directly to the next line of 60 because this is only between 50 and 59. So I'm going to stop it just before, so I'm still getting my gaps between my columns. 60 to 69 we have 9, which would be here. And 3, I'm going to complete my column graph this way. And there's my column graph. So the main thing here, remembering, is we need that gap between the columns. And part C, state the modal class for the data. So which one has the highest frequency? We can see that is the one that has 9, 60 to 69. So our modal class would be 60 to 69. Then continuous data. Data that is continuous, remember we can measure. Now when we organise this data, we'll use class intervals. And a frequency histogram is used to display the data. Once again, the modal class is a class interval with the highest frequency. Now with a frequency histogram, you'll notice here our columns are joined together. Because it is measured, we may be going all the way from 10 to 20 and then 20 to 30. Every number in that range is included, which is why there are no gaps. Quick example of this. So the weight W of each parcel sent on a given day from a post office was recorded in kilograms. Each measurement was rounded down to the nearest 0.01 kilo. Here's all our measurement. Organise the data into class intervals. Once again, we just have to look at our class intervals and see what might make sense. My lowest is 1.39, so I might start at 1 and then we'll be going up to about 8. So I'm going to do my class intervals of 1, so I'm 1 kilo. So I'm going to go from 1 all the way W, which is going to go up to 2 now. You'll see here I've put a less than or equal than on the 1 because that's where 1 will be included. But on the higher end, I've just got less than 2 because in the next one, I'm going to want it to start at 2 and that's going to be less than equal. And what this means is if I have a weight of exactly 2, I need to know where to put it. So in this case, I would put it in the second class interval because that one here includes 2. And in the first one, it doesn't include it, but goes up to 1.9999. So we still have that value included, just not 2. Just going to complete the rest of the weights. Now, do our frequency once again, go through and work out how many fit into each one. As you can do it as a tally, you can just count. So between 1 and 2, I have 1.39 and 1.63, so I've got 2 of those. Between 2 and 3, I have 4, and so on. I'll complete the table now. And then part B, find the modal class. So which one has the largest frequency? And you can see that there, that is 6. So our modal class is from between 3 and 4 kilos. Part C, draw a frequency histogram. Now remember in this one, our columns do need to touch each other. So between 1 and 2, we have 2. Between 2 and 3, we've got 4. All right, and there we have our wonderful frequency histogram. Part D, over the next month, 564 parcels are sent from the post office. Estimate the number of parcels that weigh at least 4 kilos. So to start with, we had 18 parcels. So just kind of like that stratified sampling we did, we need to work out the proportion of number of parcels that weigh at least 4 out of the current 18, and then we can multiply that by the 564. So more than 4 would be these ones here, the 4 to 8. So we'd have 3 plus 2 plus 1 equals 6. So we have 6. That's more than 4 kilos. So out of the 18, that's our proportion there, 6 out of 18. We're more than 4 kilos. And then we can multiply that by the 564 parcels to work out how many we would estimate to be more than 4. And that will give us 188 parcels.